Hello my Linians! This is Teacher Sarah and today we are going to discuss solving logarithmic equations and inequalities. This video tutorial is based from your learning activity sheets in General Mathematics, Quarter 1, Week 8. So, bring out your learning activity sheet and turn your learner's module to pages 111 to 120. Our learning targets are: represent real-life situations using logarithmic functions, distinguish logarithmic function, logarithmic equation, and logarithmic inequality, and solve logarithmic equations and inequalities. Before the lesson, let us have some warm-up questions. I have some questions for you to answer. Question number 1. Blank is one in which a variable occurs the exponent. A. Rational function. B. Exponential function. C. Polynomial function. D. None of these. What do you think is the answer? Time starts now. Excellent. The correct answer is letter B, exponential function. Question number 2. What exponent do you put on the base of 2 to get 16? A. 1, B. 2, C. 3, D. 4. What do you think is the answer? Time starts now. Okay, the answer is letter D, 4. In our previous lessons, you learned that concept of exponential function and how to solve problems involving exponential functions, equation, and inequalities. Now, let us proceed to the next chapter of the lesson, which is the inverse of exponential function, the logarithmic function. But before that, let us first discuss the use of logarithmic functions in our life and environment for us to fully understand and appreciate its uses. We see and use the different functions in our daily life, and logarithmic function is not an exception. Today, with the help of this module, we will discuss the use of logarithmic function in our daily living, like in earthquake intensity measurement, pH value, sound intensity measurement, gross domestic product, and expressing larger value. Some of them have example as we go in our discussion. You have learned that in exponential function, when you raise 2 in the 5th power, it will give you 32. Now, in logarithmic function, it will help you to solve when 2 is raised in which power will give you 128. We can solve this using the help of logarithmic function. That is why, in dealing with logarithmic function, it is very important and as expected that you know and master the exponential function. Before we discuss some of the application of logarithmic functions, let us first define some of the important terms that we will use as we go through our discussion. Let A, B, and C be a positive real numbers such that B not equal to 0. The logarithm of A to the base B is denoted by logarithm of A to the base B and defined as C equals logarithm of A to the base B if and only if B raised to C is equal to A. Common logarithm are logarithm with a base 10. Logarithm of x is the short term for logarithm of x to the base 10. So, common logarithm is found in our calculator. So, when you press the logarithm, so it is always have a base of 10. Natural logarithm are logarithm to the base e, approximately equal to 2.718 and denoted by ln. In other words, ln x is another way of writing logarithm of x to the base e. Let us study how to change logarithmic equation in exponential equation. Let us study the figure below. The logarithmic function to the base b, where b is greater than 0 and b is not equal to 1, is defined. Y equals logarithm of x to the base b if and only if x equals b raised to y. So y equals logarithm of x to the base b is in logarithmic form, while x equals b raised to y is expressed in exponential form. So x in logarithmic form and x in exponential form is called the power. Then base in logarithmic form b is the same as in base in exponential form, and it is called the base. When you convert an exponential to logarithm form, notice that the exponent in the exponential becomes what the log is equal to. So the y variable in logarithmic form and the exponent y in exponential form, or the variable y in the exponential form, is exponent. Example, convert the given exponential form to logarithmic form. 16 equals 4 to the second power, and it should be logarithm of 16 to the 4 equals 2. So the 4 is the base, while 16 is the power and 2 is the exponent. Convert the given logarithm to exponential form. Logarithm of 1 over 8 to the second power to the base 2 is equal to negative 3. In exponential form, it is 2 raised to negative 3 equals 1 over 8. So 2 the base, then negative 3 is the exponent, 1 over 8 is the power. So logarithms equals exponent. With this in mind, we can answer questions about the logarithm. So logarithm of 16 to the base 2, this is asking for an exponent. What exponent do you put on the base of 2 to get 16? So 2 to the what is 16. So that is equal to 4. Another, logarithm of 1 over 9 to the base 3. What exponent do you put on the base of 3 to get 1 over 9? Think a negative number. So that is negative 2. So logarithm of 1 to the base 4. What exponent do you put on the base of 4 to get 1? So that is equal to 0. logarithm of the square root of 3 to the base 3. This time, it is radical. So, when working with logarithms, rewrite any radicals as rational exponent. So, we have logarithm of 3 raised to 1/2 to the base 3. And that is equal to 1/2. So, therefore, logarithm of 3 raised to 1/2 to the base 3 is equal to 1/2. Change logarithm of 100 equals 2 into exponential equation. Remember that logarithm of a is just a short term for logarithm of a to the base 10. In this example, the base is 10 and the exponent is 2. So, in exponential form, it is written as 10 to the second power equals 100. Change ln x equals 20 into exponential form. Again, take note that the ln x is the shorter way of writing logarithm of x to the base e. Hence, it is written as e raised to 20 is equal to x. Now, let us discuss some of the application of logarithms in real life. The most common are the Richter scale, sound intensity, and pH level. In 1935, Richter scale proposed a logarithmic scale to measure the intensity of an earthquake. He defined the magnitude of an earthquake as a function of its amplitude in standard seismograph. The magnitude R of an earthquake is given by the formula R equals 2/3 logarithm of E over 10 raised to 4.40, where E in joules is the energy released by an earthquake. The formula indicates that the magnitude of an earthquake is based on the logarithm of the ratio between the energy it releases and the energy releases by the reference earthquake. Example: suppose an earthquake released approximately 10 raised to 10 joules of energy. What is its magnitude in a Richter scale? Since E equals 10 raised to 10, then R equals 2/3 logarithm of E, which is 10 raised to 10 over 10 raised to 4.40. So, equals 2/3 logarithm of 10 raised to 5.6. Since by the definition, logarithm of 10 raised to 5.6 is the exponent by which 10 must be raised to obtain 10 raised to 5.6 equals 5.6. Thus, R equals 2/3 times 5.6 or approximately equal to 3.73. For sound intensity is expressed in unit of decibel. So, decibel equals 10 times logarithm of I over 10 raised to negative 12. In acoustic, the decibel level of sound is where I is the sound intensity in watts per square meter. So, example, the decibel level of sound in a quiet place is 10 raised to negative 8 watts per square meter. What is the corresponding sound intensity in decibel? So, D equals 10 times logarithm of 10 raised to negative 8 over 10 raised to negative 12. So, D equals 10 times logarithm of 10 raised to 4, applying the law of exponent. So, by definition, logarithm of 10 raised to the 4th is the exponent by which 10 must be raised to obtain 10 to the 4th. Then, logarithm of 10 raised to the 4th power is 4. Hence, D equals 10 times 4 equals 40 decibel. pH value is another example of logarithmic function in scientific concept. The measure of acidity of a liquid is called pH of the liquid. This is based on the amount of hydrogen ions in the liquid. The formula for the pH is pH equals negative logarithm of hydrogen ions, where H positive is the concentration of hydrogen ions. A solution with a pH of 7 is neutral. Those with pH less than 7 is acidic, and those with pH greater than 7 is basic. Example, a 1 liter solution contains 0.001 moles of hydrogen ions. Find its pH level. Since there are 0.001 moles of hydrogen ions in 1 liter, then the concentration of hydrogen ions is 10 raised to negative 3. The pH level is negative logarithm of 10 raised to negative 3, since logarithm of 10 raised to negative 3 is the exponent by which 10 must be raised to obtain 10 raised to negative 3. Then, logarithm of 10 raised to negative 3 is equal to negative 3. So, applying the power rule. Thus, pH equals negative logarithm times hydrogen ions equals negative times negative 3 equals positive. So let us look to this example. Let's say you join a nutritional program and the program allows you to gain muscle in such a way that it is modeled by the function. So P of x equals logarithm of x plus 1, where P of x is the number of pounds of muscle you gain and x is the number of days on the program. Using the formula given, you can check the expected pounds of muscle that you will gain if you stay to the program for about 2 days, 3 days, or even 1 week. So let's distinguish logarithmic function, equation, and inequality. Do you hear from your mathematics teachers or from your older peers, or maybe you already encountered the terms logarithmic function, logarithmic equation, and logarithmic inequality? Do you know the differences between them? So today we will discuss the differences between the three. For logarithmic equation, these are some examples. We have logarithm of 2 to the base 2 equals x, logarithm of 16 to the base 4 equals x. Another, we have logarithm of 25 to the base x equals 2. Then we have logarithm of x to the base 3 equals 5. Logarithmic function. Like a logarithmic equation, logarithmic function has equal sign. But unlike logarithmic equation, logarithmic function has two variables, that is x and y. Logarithmic function expresses a relationship between two variables. It can be represented by a table of values or by the means of graph. Another way to know if the given is logarithmic function is to observe if it's involved f of x, g of x, h of x, etc. So for you to understand it more, let us consider the following examples. Y equals logarithm of x to the base 2. So there are two variables involved. We have the x and y, and it has an equal sign. So another example, we have logarithm of a to the base 2 equals b. So another variables involved, we have variable a and b. More examples of logarithmic function are illustrated below. F of x equals logarithm of x to the base 3. G of x equals logarithm of x to the base 5. H of x equals logarithm of x to the base 6. F of x, g of x, and h of x is y. So therefore, there are two variables involved in the given example, such as x and y. And for logarithmic inequality, it looks like logarithmic equation, but the only difference is instead of using equal sign, it uses inequality sign like less than or equal to, greater than, and greater than or equal to. Example, logarithm of 8 to the base 2 is greater than x. So again, it has one variable called x, and the inequality sign is greater than. So more example of logarithmic inequalities are logarithm of 9 to the base 3 is greater than x, and logarithm of 64 to the base 4 is less than b. To summarize the differences between logarithmic equation, logarithmic function, and logarithmic inequality, you may refer to the table below. Okay, next, let's tackle the basic properties of logarithms. By definition, you let b and x such that b greater than 0 and b not equal to 1. Properties of logarithms are as follows. Property 1, logarithm of 1 to the base b equals 0. Property 2, logarithm of b raised to x to the base b is equal to x. Property 3, if x greater than 0, then b raised to logarithm of x to the base b is equal to x. And for the laws of logarithms, there are laws that we need to consider. Let b greater than 0, b not equal to 1, and m and n greater than 0. Then we have logarithm of mn to the base b. So equals logarithm of m to the base b plus logarithm of n to the base b. So that is the product rule. Then number 2, logarithm of m over n to the base b equals logarithm of m to the base b minus logarithm of n to the base b. So we call it the quotient rule. So you subtract. Then for number 3 laws, logarithm of m raised to p to the base b is equal to p times logarithm of m to the base b. So this is called the power rule. And to apply the following rules of logarithms, let's have some example. You perform the following using the different rules of logarithms. Expand logarithms of 2x to the third over 5 to the base b. So you may apply the quotient rule. So to apply quotient rule, so you are going to use the definition of quotient rule. So we have logarithm of 2x to the third to the base b minus logarithm of 5 to the base b. So you subtract. Then you simplify. So you apply the product rule. So we have 2 and x to the third power. So you use the definition of the sum of the product. So we have logarithm of 2 to the base b plus logarithm of x to the third to the base b minus logarithm of 5 to the base b. Then you apply the power rule. So we have logarithm of 2 to the base b plus the exponent 3 multiplied by logarithm of x to the base b minus logarithm of 5 to the base b. Okay, to condense, meaning you make this given logarithm a single one. So we have 4 logarithm of y to the base a plus logarithm of x to the base a minus logarithm of b to the base a minus 5 times logarithm of d to the base a. So you may apply the power rule. So we have logarithm of y to the 4th power to the base a plus logarithm of x to the base a minus you group logarithm of b to the base a plus logarithm of d raised to 5 to the base a, applying the power rule. Then applying the product rule. So we have logarithm of x y to the 4th to the base a. So the sum of logarithm, so this is the product, then minus, again you combine them since this is the sum. So the product is logarithm of b times d to the 5th power to the base a. And then you apply the quotient rule to make or to express this in single form of logarithm. So we have logarithm of xy to the 4th over b d to the 5th power to the base a. Okay, next, solving logarithmic equation and inequalities. So there are properties of logarithmic equations that we need to consider also. If b is greater than 1, then the logarithmic function y equals logarithm of x to the base b is increasingly for all x. If 0 less than b less than y, then the logarithmic function y equals logarithm of x to the base b is decreasing for all values of x. This means that logarithm of u to the base b equals logarithm of v to the base b if and only if u is equal to v. Some strategies in solving logarithmic equation. First is rewriting to exponential form. B. Using logarithmic properties. C. Applying the one-to-one property of logarithmic function. And D. The zero factor property. If AB equals 0, then A equals 0 or B equals 0. Example, find the value of x in the following expression. Logarithm of 3x to the base 3 equals logarithm of 12 to the base 3. So same basis. So you may apply a one-to-one property. Therefore, u equals v. So we have 3x equals 12 or x equals 4. Then check 4 is a solution since logarithm of 3 times 4 equals logarithm of 12 to the base 3 is defined. Therefore, the value of x as 4 is correct. Then, we have logarithm of quantity x minus 2 to the base 4 equals 2. So we have to change logarithmic form into exponential form. So we have the power quantity x minus 2 equals the base 4, then exponent is 2. Then solve for the value of x. So this becomes x minus 2 equals 16. That is the equivalent of 4 to the second power. Then applying property of equality, or you may use the shortcut way, you transpose negative 2 to the right side, that it becomes positive, therefore x equals 18. And then again you may check, we have logarithm of 18 minus 2 to the base 4 equals 2. So we have logarithm of 16 to the base 4 is equal to 2. So therefore x equals 18 is correct. Number 3 example, logarithm of 25 to the base x equals 2. This time the base is unknown. So first step is to change the logarithmic form into exponential form. So the base is x, the exponent is 2, equals the power, which is equal to 25. So we have to square, or we have to find the square root of 25, and that is x equals positive negative 5. Then you can also check it to find out if the value of x is correct. So 5 is a solution since logarithm of 25 to the base 5 is defined. However, negative 5 is not a solution since logarithm of 25 to the base negative 5 is not defined because the base cannot be negative. Example number 4, logarithm of quantity x plus 1 to the base 2 plus quantity x minus 1 to the base 2 is equal to 3. So applying the product rule, so we have to get the logarithm of quantity x plus 1 and quantity x minus 1 to the base 2. Then change in exponential form. So the power is quantity x plus 1 times quantity x minus 1 equals base 2. Then the exponent is 3. So we have to expand or find the product of the sum and difference of x and 1. So we have to find the product, that is equivalent to x squared minus 1 equals 8. Then to simplify, it becomes x squared minus 9 equals 0. So therefore, by factoring, the factors of x squared minus 9 are quantity x plus 3 and quantity x minus 3, then equate to 0. Therefore, x equals 3 and negative 3. 3 is a solution since logarithm of 3 plus 1 to the base 2 and logarithm of 3 minus 1 to the base 2 are defined. However, negative 3 is not a solution because logarithm of negative 3 plus 2 to the base 2 equals logarithm of negative 2 to the base 2 is not defined. So number 5, we have 3 raised to x equals 5. Applying 1-to-1 property of logarithm, so we have logarithm of 3 raised to x equals logarithm of 5. Then applying the power rule, since 3 is a positive, so we have x times logarithm of 3 equals logarithm of 5. Then divide both sides by logarithm of 3. So x equals logarithm of 5 divided by logarithm of 3. So x is approximately equal to 1.46497 using your calculator. So you may check that using your calculator. Properties of logarithmic inequalities. If 0 less than b less than 1, then x of 1 less than x of 2. If and only if logarithm of x of 1 to the base b is greater than logarithm of x of 2 to the base b. So if b greater than 1, then x of 1 less than x of 2. If and only if logarithm of x of 1 to the base b is less than logarithm of x of 2 to the base b. Let's have an example. Find the value of x in the following logarithmic inequalities. 1. Logarithm of quantity 3x minus 1 to the base 7 is greater than logarithm of quantity x plus 2 to the base 7. For step 1, you ensure that the logarithms are defined. So since they are same bases, applying one-to-one property of inequality, so we have quantity 3x minus 1 greater than 0 and quantity Step 2. Ensure the inequality is satisfied. The base is 7 and it is greater than 1. So thus, since logarithm of quantity 3x minus 1 to the base 7 is greater than logarithm of quantity x plus 2 to the base 7, then applying property 2, note that b is greater than 1. So we have quantity 3x minus 1 greater than quantity x plus 2, then add negative x and negative 2 on both sides. We have 2x greater than 3, then add 3 on both sides. So we have x greater than 3 halves. So by multiplying 1 half on both sides to solve for the value of x. So the solution set is x greater than 3 halves. In interval notation, we have 3 halves and positive infinity. Example number 2, logarithm of quantity 2x plus 1 to the base 3 is less than logarithm of quantity 5x minus 2 to the base 3. So reverse the inequality, becomes logarithm of 5x minus 2 to the base 3 is greater than logarithm of 2x plus 1 to the base 3. Ensure that the logarithms are defined. So we have same bases. Quantity 5x minus 2 greater than 0 and quantity 2x plus 1 greater than 0. To solve for the value of x in quantity 5x minus 2 greater than 0, so you have a value for x as x greater than 2p And for 2x plus 1 greater than 0, x is greater than negative 1/2. To make both logarithms defined, then x greater than 2/5. If x greater than 2/5, then x is surely greater than negative 1/2. Ensure that the inequality is satisfied. The base 3 is greater than 1. So logarithm of quantity 5x minus 2 to the base 3 is greater than logarithm of quantity 2x plus 1 to the base 3. Then same basis. So you apply property 2 where b is greater than 1. So we have 5x minus 2 greater than 2x plus 1. Then to simplify, by adding negative 2x and negative 1 on both sides, becomes 3x minus 3 greater than 0. By adding 3 on both sides, to simplify, 3x greater than 3, and multiply both sides by 1/3 to solve for the value of x. X is greater than 1. The solution set, x is greater than 1, then in interval notation, that is 1 to positive infinity. Example number 3, logarithm of quantity 2x plus 1 to the base 1/2 is less than logarithm of quantity 5x minus 2 to the base 1/2. You reverse the direction. Logarithm of quantity 5x minus 2 to the base 1/2 is greater than logarithm of quantity 2x plus 1 to the base 1/2. Ensure that the logarithms are defined. Since they have the same basis, you apply property 2 where b, or the base 1/2, is less than 1. So we have 5x minus 2 greater than 0 and 2x plus 1 greater than 0. To solve for the value of x, for 5x minus 2 greater than 0, x is greater than 2/5. And for 2x plus 1 greater than 0, x is greater than or negative 1/2. To make both logarithms defined, then x is greater than 2/5. If x greater than 2/5, then x is surely greater than negative 1/2. Ensure that the inequality is satisfied. So the base 1/2 is less than 1. So we have logarithm of quantity 5x minus 2 to the base 1/2 greater than logarithm of quantity 2x plus 1 to the base 1/2. Then you are going to reverse the direction of the inequality because the base 1/2 is less than 1. So we have quantity 5x minus 2 less than quantity 2x plus 1. Applying property 1, note that 0 less than b less than 1. So you add negative 2x and negative 1 on both sides. That becomes 3x minus 3 less than 0. And then add 3 on both sides. So we have 3x less than 3. And then to solve for the value of x, you multiply both sides by 1/3. So we have x less than 1. So x less than 1, but it must be greater than 2/5 to make the inequality defined. So the solution set 2/5 less than x less than 1. In interval notation, that is 2/5 and positive 1. So number 4, logarithm of 3x plus 2 to the base 2/3 less than or equal to logarithm of 7 x minus 3 to the base 2/3. So we have logarithm of quantity 7x minus 3 to the base 2/3 greater than or equal to logarithm of quantity 3x plus 2 to the base 2/3. So ensure that the logarithms are defined. We have quantity 7x minus 3 greater than 0 and 3x plus 2 greater than 0. Then solve for the value of x. For 7x minus 3 greater than 0, x is greater than 3/7. And for 3x plus 2 greater than 0, x is greater than negative 2/3. To make both logarithms defined, then x greater than 3/7. If x greater than 3/7, then x is surely greater than negative 2/3. Ensure that the inequality is satisfied. The base 1/2 is less than 1. So logarithm of quantity 7x minus 3 to the base 2/3 is greater than or equal to logarithm of quantity 3x plus 2 to the base 2/3. Then you reverse the inequality since the base 1/2 is less than 1. So we have quantity 7x minus 3 less than or equal to quantity 3x plus 2. So applying property 1, note that 0 is less than b less than 1. So to simplify, so you add negative 3x and negative 2 on both sides. So becomes 4x minus 5 less than or equal to 0. So then to solve for the value of x, you add positive 5 on both sides. So it becomes 4x less than or equal to 5, and then multiply both sides by 1/4 to solve for the value of x, and x becomes less than or equal to 5/4. So x less than or equal to 5/4, but it must be greater than 3/7 to make the inequality defined. So the solution set is 3/7 less than x less than or equal to 5/4. In interval notation, that is 3/7 and 5/4. So the value of x is equal to 5/4. 5/4 is included, no? And those value that is less than 5/4. At this point, turn your activity sheets to enrichment part to do your task. Reminder, do not write anything on this activity sheet. Write your answer on a separate long bond paper. For enrichment activity 1, you read each item carefully, then choose the letter of the correct answer, then write on your answer sheet. For enrichment activity 2, letter A, determine whether the given is a logarithmic equation, logarithmic function, or logarithmic inequality. Then letter B, express the following logarithms into exponential forms. Write your answer on your answer sheet. And for enrichment activity 3, you express the following logarithms into exponential form. And for wrap-up activity, you are required to answer the following questions. It's give you additional point or bonus point that should be added in your score in enrichment activity. I hope you learned something today. If you have questions or clarifications regarding the topic we discussed, feel free to contact your subject teacher through text, call, or post your questions in your official Facebook group or page. Thank you for watching. Don't forget to like and subscribe.